Hello, fifth grade. Let's take a look at a couple of these figures and see which have the same volume. So I have 5 different figures here, and we know that to find the volume, we're going to multiply our length times our width times our height. So this example has listed out the length, width, and height that I need for every single figure. So let's figure out which may have the same volume. As I look up here in figure 1, I notice that I've got a length of 8, a width of 5, and a height of 5. 8 times 5 times 5 equals 200. Looking at figure 2, length of 7, width of 4, height of 7. 7 times 7 I know is 49. I'm going to jot this down here. 49 times 4. So remember, this is multiplication. I can rearrange these numbers however I'd like to make it easiest for me. So 49 times 4. 9 times 4 is 36. 4 times 4 is 16, plus that 3 is 9. So figure 2 has a volume of 196. Jot down that 200 from figure 1 as well. Figure 3. Length of 10, width of 20, height of just 1. So we've got one long layer here. I know that 10 times 20 is 200. 200 times 1, of course, is still 200. Looking at figure 4. To find my volume, multiplying my length 10 times my width 6 times my height of 3. I know that 10 times 6 is 60. 60 times 3, I know that 6 times 3 is 18, so putting that 0 on the end because I'm multiplying by a multiple of 10 is 180. Finally, over here looking at figure 5. Length of 9, width of 5, height of 4. I know that 5 times 4 is 20. 20 times 9 would give me 180. So as I compare the volumes of these figures, I can see, let me change my color, that figure 1 and figure 3 have the same volume. They look very different from one another, but the volume that they have is exactly the same. If I were to imagine these were empty boxes, that these boxes could be filled with things, I would not be able to fit and fill box or figure 1 with the same types of materials that would fill figure 3 in most cases. But if I use something like sand, water, something that fills the space completely, I would take the same amount of sand to fill figure 1 as to fill figure 3. Though they look very different in dimensions, their volume is the same. They're holding the same amount. It's the same down here as we look at figures 4 and 5. They both have a volume of 180 unit cubes. So 180 of these little 1 by 1 unit cubes can fit in both of these figures. These two look a little more similar in their shape and dimension than figures 1 and 3 do. They have the same volume here. So as you are looking at comparing volume, don't let the actual dimensions of each shape fool you, because that volume can be the same as a shape that may look completely different. It all depends on the dimensions when we multiply all 3 together, how much they can hold.